Solving quadratic inequalities. So first, what's a quadratic inequality? It's in this form. So it's a normal quadratic equation, but now we're going to have an inequality. It could be less than, it could be greater than, it could be less than equal to, greater than equal to. But when you have this, it's a quadratic inequality. And we solve this differently. When you solve an inequality, it's always going to be an interval. So when you solve an inequality, it's always an interval. So let's look at an example. Let's say I graph a quadratic, and I get something like this. So if I ask you where does this guy equal 0 at, that's the x-intercept. So that's here and here. If I want to know where is it less than 0, where's my graph here less than 0, you can see it's the pink, right? The x-axis is essentially the 0. So anything above that is where you're greater than 0. Anything below that is where you're less than 0. Now this is an inequality that's only less than, so that's why it's an open circle, open parenthesis. And then greater than will be over here, parenthesis. If the graph is upside down, then you just kind of flip it. Where are you equal to 0? X-intercepts. Where are you less than 0? Or below the x-axis, so here and here. And where are you greater than 0? Above the x-axis, here and here. So you can see like this one. If I was like, what's the answer here? When is this function below? When is f(x) less than 0? So here's my f(x). It'll be less than 0 when you're below the x-axis. So this little inside portion right here. As you can see from here to here. So my answer there would be from -2 to 3 would be the answer. So you're starting at -2, that's where you're below, and then you go all the way to 3. If I ask you where you're greater than 0 at, well, look at the exact same picture, right? The graph is above the x-axis here and here. Now again, the answers I want is the x-axis. Like when does this start being above the x-axis? Here at 3 to infinity, because it just keeps on going. And on this side, -infinity all the way to -2. Bracket with the equal to sign. So that'll be my answer. -infinity to -2, union 3 to infinity. That's right. So less than 0 is below the x-axis, where your graph below the x-axis. Greater than 0 is where your graph's above the x-axis. So let's do another example. Brand new graph. I want to know where I'm less than 0. So again, here's my x-axis. This is equal to 0. This is where my y equals 0. Right, so I want to be below that. So anything below that. So where's my graph below the x-axis? So it would be from here to here and from here to here. Right, so that's where the graph is below the x-axis. Now, what's my answer? So where does this start? Farthest left is an arrow, so that's -infinity. And it goes all the way to hit the x-intercept right there at -4. Now notice that it's not an equal to sign, so it's a parenthesis. If it was an equal to sign like the last one, it would be a bracket because of the equal to sign. It means you can be the value. Over here we can be the value. And actually my equal to sign should be an open circle. It should be like this from here on. And then where are my lessons are on this side? Well, from here, right? From 2 on. So you can write open circle there, and then on, all the orange here. So my answer is going to be from 2 to infinity. And on this side, I mean, I should have done it this way, right? From -infinity to -4. So those are my answers. -infinity to -4, union 2 to infinity. That's where your graph is below the x-axis. So same thing we talked about before. If I was to make this actually useful, because it's the same picture, let's make this equal to signs. In that case, these are brackets. No brackets at the infinities, because infinities, remember, you can never touch infinity, so it's always a parenthesis. Same thing here. Let's make it an equal to sign. These just become brackets. So there we go. What if your graph is above it and never touches the line? Well, then where does your function equal 0? Well, there's no x-intercept, so never. When's your function less than 0? Well, it's never less than 0. So I'm always above it in this picture, so never. And when it's greater than 0, the whole way, -infinity, +infinity. And then vice versa for this one, right? Where does it equal 0? No x-intercept, so never. Where is it less than 0? It's always less than 0, so -infinity, +infinity. And when is it greater than 0? It's never greater than 0. It's never above the x-axis, so never. So if you get a graph that doesn't have an x-intercept, that only has imaginary roots, that's how it's solved. Okay, so let's talk about how to actually solve quadratic inequalities themselves. It's one of those things where there's actually two ways to do it. Way one, we're going to call it the graphical way. Now remember which way to do it? Like the first two steps are kind of the same. So way one, what we're going to do is we're going to set equal to 0, or inequality equal to 0. Then we're going to solve like normal. And then we're going to do a basic graph using the x-intercepts. So remember, when you solve it like normal, you find x-intercepts. Let me erase that and put solve quadratic to find x-intercepts. And then use graph to determine the answer to the inequality. So that's going to be our steps. We're going to set equal to 0. We're going to solve like normal. So we're going to set equal to 0. We're going to solve the quadratic. When we solve the quadratic, we find x-intercepts to find x-intercepts. Then we're going to graph it. Do a very basic graph just using the x-intercepts. And we'll use that to determine what the answer to the inequality is. So look at this one here. It's already set equal to 0 for us. We just got to solve. We just got to solve x squared minus x minus 12 is equal to 0. So easiest way to solve this is by factoring. You can also do quadratic formula, but factoring is by far the easiest here. Two things that multiply to get negative 12, to add to get negative 1 would be negative 4 and 3. Right, if I multiply those two, I get negative 12. If I add those two, I get negative 1. So my factor is negative 4 and x plus 3 equals 0. Now we could split it. X would set each one equal to 0. And we would get x equals 4 and negative 3. So these are my x-intercepts. Right, because those are my zeros, my solutions, and my x-intercepts. Now we're just going to graph this super basic. So all I'm going to do is draw an x. I don't know why I switched colors. All I'm going to do is draw an x-axis. Our x-intercepts are 4 and negative 3. Notice I'm not even drawing the in between it. All I care about is negative 3 and 4. Now this is a parabola. Now do you remember, does it open up or does it open down? Look at your A. Right? My A here is 1. So remember what happens when your A is positive? It opens up. If my A was negative, it would open down. So my graph here is going to open up. Right? It's just a basic graph so I understand is it open up or down. Now what was the question? We want to figure out where this graph is less than 0. So look at this graph here. Where are you less than 0? And you should say from here to here. Right? That's where the graph is less than 0. From negative 3 to 4, my graph, the graph is below the x-axis. So your answer is from there to there. Now, it is only an equal to sign, less than sign, no equal to, so it should be parentheses from negative 3 to 4. And that's the answer. From negative 3 to 4, this graph is below the x-axis. It's less than 0. So that's one way to do it. Another super popular way is using a sign chart. So you can see here. So in this graph, they have the exact. You could also look at this as a sign chart. So you look at this graph here. You can make a sign chart. Everything left of my x-intercept is positive because it's above the x-axis. Everything between these two is negative because it's below the x-axis, and everything above it, everything to the right of 3 is above the x-axis again, so it's positive. So this will give you the exact same answer. And we're going to do it one more time using a sign chart because some people prefer that. So we'll do this. We'll do way 2, the sign chart way. So the first steps are still the same. Set equal to 0. Solve to find x-intercepts. On this one, instead of graphing it, we're just gonna plot. We're gonna make a sign chart. with the x-intercepts. Right, so instead of making a graph, we're going to make a sign chart with the x-intercepts. And then we're going to pick points to see if positive or negative to get our answer. So, exact same question. We already know the factor. It's x minus 4, x plus 3 is equal to 0. We're going to split x equals 4, x equals negative 3. So in this case, I'm still going to make it like a number line type of thing. And I'm going to go, here's negative 3 and here's 4. Now what's the difference here? Instead of doing a graph to figure out where's above or below, maybe it's hard for you to see where it's like, where's it above and where's below? What I'm going to do is this. We have three answers here. I like to circle the numbers. My x-intercepts. And so our answers are going to be the left of negative 3, and between negative 3 and 4, or to the right of negative 3. And all we do now is we pick test points. Pick test points between each value to sub into original equation. So we're going to pick a test point for each one of these. So negative 3, we need something left of negative 3, something like negative 4. We need something between negative 3 and 4. A lot of times people pick a 0. And we need something to the right of 4, something like 5. Now we could plug it into, we want to either plug it into the original equation or the factored form of it, which is a little bit easier in general. So you can plug into this and see if it works. Or you can plug it into the factored version of this, which is x minus 4, x plus 3 is less than 0. And all you want to see is the positive or negative. That's all we care about. So like negative 4, let's plug negative 4 into the factored version. Negative 4 minus 4 is negative 8. If I plug this into here, right, negative 4, negative 4. Negative 4 minus 4 is negative 8. Negative 4 plus 3 is negative 1. Negative 8 times negative 1 is a positive 8. Only it matters to me that it's positive. It's a positive number. Let's plug in 0. So again, you can plug into the original equation or you can plug into the factored version. Doesn't matter. So we plug into here. Again, all I care about is if it's plus or minus. 0 minus 4 is negative 4. 0 plus 3 is 3. 3 times negative 4 is negative 12. Again, all I care about is the fact that it's negative. Same thing with 5. You could plug 5 into the original if you want to, or into the factored form. I haven't plugged it into the original. I'm going to plug into the original just to show you. So I get 5 squared minus 5 minus 12. So I get 25 minus 5 minus 12. 20 minus 12 is 8. So I get a positive number. So we have this. Right, so what does this tell me? Well, only thing I want is where it's less than 0, right? Which one's less than 0? This means negative. The fact you want less than 0 means you want a negative number. So my answer is the middle. From negative 3 to 4. So that's two ways to do it. One way is to make a sign chart, pick test points, plug those test points into your original equation or the factored form, and see if it's plus or minus. And then how you tell which one do you want? It all depends on if you want a negative or positive. So that's way 2, I say. Way 1, do most of the same things, right? Factor it, get your critical points, graph your critical points. But in this case, now you do a quick graph. If it's a positive x squared, it should open up. If it's a negative x squared, it should open down. And then just go. Less than will be where you're below the x-axis. Greater than is where you're above the x-axis. That's kind of the idea. So we're going to do a couple more examples to see the hang of it. But that's the general idea. So let's look at this one. So step 1, remember, set equal to 0. So we're going to move this stuff over. Let's add 5x. Let's subtract 12. So 2x squared plus 5x minus 12 is greater than or equal to 0. Now we just got to solve this. We can solve any way we want. We can do quadratic equation. We can do complete the square for crazy. Or we could factor. Again, it is your choice. this actually factors, so I'm going to factor it because I think factoring is generally the quickest if you know how to do it. So I multiply the first term and the last term to get negative 24 x squared. And then I need two things that multiply to get negative 24 but add to get negative to positive 5. Since it is a negative 24, to me different signs. So negative 8x and plus 3x. 8x times 3 would be 24. Negative x plus 3 will get you, wrong way. Positive 8, negative 3. There we go. Right, that'll give me the positive 5. The other way around would have got me negative 5. And again, you could also do, remember, don't forget, you could solve this by completing this by quadratic form if you want. I'm just doing it this way because I know how to solve it. So 2x squared. My middle now is plus 8x minus 3x minus 12 is greater than or equal to 0. So I'm going to factor by grouping. So I get 2x, x plus 4. Bring down the middle sign. These have a 3 in common, so factor with the 3. Now, very important. Remember, it's not negative 12 divided by 3. That gets me negative 4. It's negative 12 divided by negative 3, which changes the sign and gets me positive 4. So I factor these out. I get x plus 4, 2x minus 3 is greater than or equal to 0. Split and solve. We got to find our x-intercepts. Again, that's what you could, if you want, you could do this quadratic formula way. I'm going to get x plus 4 equals 0. 2x minus 3 equals 0. So x equals negative 4. 2x equals 3. X equals 3 halves. Like that. So those are my x-intercepts, or my critical points, whatever you want to call them. Now, I think the easiest way to solve this is by graphing. So we're going to graph this. Remember, we're not going to go crazy with it. We just graph the 2 points. Negative 4 will come first because it's the most left, and then 3 halves. And then I look at my graph, and I say, look right here. I want this to be greater than, well, first of all, it's a parabola, and it's a positive parabola. So this right here lets me know it's an open up. So all I gotta do is draw it, going through these points and opening up. Now what do I want? I want this to be greater than 0. So where's the positive? So the middle is below 0, it's below the x-axis. It would be this side and this side. So where's that as my answer? It is from, whoops, kind of works. It is from negative 4 all the way to the left. So negative infinity to 4 with the bracket, because again, equal sign. Negative 4, by the way. Right, because that's an equal sign. So negative infinity to negative 4. And on this side, from 3 halves to infinity. So there's my answer. So something like that. Right, so the factoring is a little worse, but it's the same concept. Set equal to 0, solve it any way you want to solve it, factor quadratic formula, get your x-intercepts, and then just quickly graph the x-intercepts. Again, just a quick sketch. All you do is plot the points. Does it open up or down? And then from that you should know. Let's do one more of these. So now this one is not factorable. So we're just going to do one of these. They're both the same. So this one's not factorable. So the only way to solve this one is either complete the square or use a quadratic formula. So I'll do the quadratic formula here, because I think that's what most prefer. Complete the square is probably a little bit easier in this case, though. So I have my a, b, and b. It's already set equal to 0, so I have my a, b, and c. So we need a quadratic formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. So let's type my values in. So negative 4 plus or minus square root of negative 4 squared minus 4 times 1 times 2 all over 2 times 1. Okay, let's simplify it a little bit. This is 16. Remember, anytime you square anything, it becomes positive. Minus 8, and this is 4, so I get 4 plus or minus radical 8 over 2. I can simplify it a little bit, that'd be, but this is stuck with here, so I get 4 plus or minus rad 8 over 2. Now let's do a number line. Now remember, this is actually two answers. It's 4 plus rad 8 over 2 and 4 minus rad 8 over 2. Which comes first? Well, 4 minus rad 8 over 2 would come first. And then over here would be 4 plus rad 8 over 2. Again, all we have to do is a simple sketch. So does this graph move up and down, up or down? It is a positive A, so it opens up again. All these graphs have been opened up so far. So you just draw like a sketch. Oops. Probably should go through the actual line. Right, nothing special, just something like that. And what do I want? I want my graph to be less than 0. So we're on this graph on my less than 0. Well, from here to here, right, where your graph is actually below the x-axis. So from here to here is your graph's less than 0, which means your answer is the x value. It's like a win. Notice it's an equal to sign. So from here all the way to here. So from 4 minus rad 8 over 2 to 4 plus rad 8 over 2. Would be my answer. Just went from there to there. Okay, almost done. Last thing. Let's talk about a solve for. So we're going to solve for equation formulas again, but this time we're going to have squares in them. So the main difference here from when we did in chapter 1 is leave plus or minus in your answers. So you're going to take a square root at some point. Don't forget the plus or minus. So let's do example 1. They want us to solve for d. So they want to solve for d right there. So remember, when we do this, you want to treat everything else like a number. So how do I get rid of the, let's get rid of the fraction. Let's get rid of the 4. How do you do it? Just like you do with any number. Multiply by the reciprocal. So I get 4, and I have a fancy a, I'm just going to write a, pi d squared. Now I have a pi there I want to get rid of. Well, how do you get rid of it? Well, it's being multiplied, so divide. So now we have 4a over pi equals d squared. We gotta get rid of the squared, so we're gonna square root both sides. Don't forget when you square root, you should get a plus or minus. So we're gonna have plus or minus 4a over pi equals d. And that's all it is. Next one, let's do the next one real quick. So same thing here, rt squared minus st squared. I want you to solve for t. This one's pretty ugly. So notice that we have 2 t's. So the way we're going to solve for t here is we got to do a quadratic equation. So I have rt squared minus st equals negative, minus k equals 0. We want to set equal to, because this is a quadratic. We're going to set equal to 0 and solve it like a quadratic equation. Right? X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Now, this is one of the few times where I'm going to tell you plug values in for a, b, and c. Right? What's our a, b, and c? Our a is the thing next to your x squared, so my a is r. My b is the thing next to s. T, so the thing next to t, so that's my b, and this will be my c. Right? Our variable here is t, so we're gonna treat it like the quadratic formula. Now the good thing is I don't have to simplify very much. We just have to plug it in. So x equals negative s. That's ugly. So we're just going to plug our stuff in. So it's going to be negative s is my b. So this is negative s squared minus 4 times a, which is r, and c, which is negative k. And my a here is r. So we simplify a little bit. Double negative cancel. I say just get s. Plus or minus. Negative s squared is just s. Now watch out here. Negative 4 times negative k is positive. So you have plus 4rk, or kr, all over 2r. And that's it. You can't really do anything else with that. Stop there, and we are done.